Okay, so like I said, we are starting our exponential functions today. What is an exponential function? It's a function of the form f of x, which f of x is just a fancy y. Remember, f of x and y are interchangeable. So f of x equals a times b to the x power. Looking at your function, looking at the equation, where do you see x? It's that one right there. Where do you see x, guys? So if x is the exponent, it is exponential. Okay? Do we like that? An easy way to remember it. If x is the exponent, your function is exponential. Okay? A cannot equal 0, and b cannot be 1. Okay? A is your y-intercept, or your starting value. Okay? B is the growth or decay factor. This falls in line with what we did with our geometric sequences. If we look back at our geometric sequence right here, A1 was the first term's value. R was the common ratio, so what you were multiplying by. Same thing here. The A is your starting value, and the B is the growth or decay factor, what you are multiplying by. If you are growing, B is going to be bigger than 1. If you are decaying, what do you think decaying means? Decreasing, getting smaller. If you are decaying, B is in between 0 and 1. Okay? Really, guys, the only thing that is tricky with our exponential functions is this horizontal asymptote. Okay, that's how we say that, asymptote. Do y'all remember seeing that at all on the interim assessment we took last week? Any of y'all like, what in the world does that mean? Okay, you've never seen this before. This is something we've never done before. Okay, so a horizontal asymptote is a horizontal line, which we call our boundary line, that your graph approaches. Normally, you will not cross this boundary line. I'm not going to say you never will, because whenever you get into Algebra 2 and stuff like that, you will cross this boundary line. Okay, but normally, it's called a boundary line because you do not cross it. And the way you write this is y equals a number. It's an equation. It's a horizontal line. So if it's a horizontal line, that's a HOI. Horizontal lines have a slope of 0, and their equation is y equals a number. So that's why our horizontal asymptote is written as y equals a number. Your horizontal asymptote is not actually part of the graph. It just helps us graph the function. Okay? It like puts a boundary line of where my graph approaches but does not cross. Okay? So, looking here. Graph the functions. F of x equals 4 to the x power. How do I know this is an exponential function? Because x is the exponent. Very good. Guys, when we are graphing, what do we have that helps us? Our calculator. So let's all go to our calculator with me. We're going to go to y equals. Let's all go to our calculator with and go to y equals. And we're going to type in 4. Remember, we talked about this, I think, last class. You hit that arrow up, which is right below the clear button. X. 4 raised to the x power. So we're doing this on our calculator with me. 4 raised to the x power. Before we pull up the table, let's look what the graph would look like. So let's graph it. Do we see that it's like flat right there and then it grows? Have y'all ever heard of it grows exponentially? Okay, that means it grows and it gets big really, really fast. Okay? The X is right next to your green button, the alpha. Okay? So this is an example of what an exponential growth function looks like. Okay? Now we are going to go to our table to write down the values to help us graph it. So second table. -2 is 0.0625. -1 is 0.25, 0 is 1, 1 is 4, and 2 is 16. So we're just getting these values off of our table on our calculator. Now guys, when I plot this -2, 0.0625, what is that essentially just so close to? What's this number super close to? 0.1 or just 0, right? It's really, really close to 0. Okay? So whenever we're graphing these decimals, do you think they're going to be 100% accurate? No. This point should be 0, 1. That's easy to graph. And 1, 4 should be easy to graph. This 216, does that even fall on our graph? No, because my graph only goes up to 10. So when I do -2, it's basically at 0. Notice how I put it just slightly above it. And then same with the -1, 0.25. Is the 0.25 bigger than this? Yes, but very small. This is still very close to 0, so it's just slightly higher. But then 0, 1, 1, 4. Okay, don't draw your curve yet. Okay? Where do we think this graph flatlines? What do we think our horizontal asymptote is going to be? We know it's going to be y equals. But where do we see on our graph on our calculator, where does it flatline? Where does it flatline, guys? At the what axis? The x-axis, which is just a y equals 0. So, draw your horizontal asymptote over the x-axis. The way we draw it is it's a dashed line. Because it's a boundary line, it's not actually part of my graph. Okay, it just helps me graph my exponential function. So it's a dashed line over the x-axis. So then we're going to, when you draw your curve, that's what it's called, exponential functions make curves. When you draw your exponential curve, is it allowed to go below this pink line I just drew? No, so it's going to like flat line there, and then it grows up really fast. Just like when we did our lines, we have arrows at both ends. Okay, where does this hit the y-axis? So my y-intercept is 0, 1, because remember we write it as an ordered pair. Okay, what is my domain? Remember, domain is your what variable? X. Is this ever stopping going to the left? It has an arrow over there, so what does that mean? Never stops. Here, it's going up, but it's also gradually going out to the right. So is it ever stopping going right? No. So is there any restriction on what your x value can be? No. So this is where we do that uppercase double-lined R. What does that mean again? All real numbers. Is there a restriction on what my range is, what my y values can be? Did I draw a boundary line for the bottom? Doesn't my whole graph exist above this boundary line? So is there a restriction on my y values? Yeah, it cannot exist below there. There's only one boundary though. Is there a top bound? No, because I have an arrow. So I don't need to put both my bottom and my top value. I'm just going to put my bottom value. Okay, if there's only one bound, you only need to give me one number. Okay, so we're going to do y, because range is y. Do I exist above or below that boundary line? Above. So greater, because we're above it. And what's this boundary line's value? Well, it's the same as your horizontal asymptote, which is what? 0. Can you equal 0? No, we're not equaling 0. We're getting very, very close to 0, but we're never equaling 0. Okay? Are we okay with that? Okay, so this, whatever is being raised to the x, is your b value. So this is my b. 4 is being raised to the x power. Is 4 bigger or smaller than 1? So am I growing or decaying? So this is exponential growth. And it's because b is equal to 4. So remember what we set up here. If b is bigger than 1, you're growing. If b is between 0 and 1, you are decaying. So since b is 4, we are growing. Okay? Now, one other thing we're going to talk about before we move on. Right here, is there a plus or minus number? Do you see anything over here? No. Since we aren't adding anything, aren't adding a constant, the horizontal asymptote is at y equals 0. If I had like plus 8 over here, my horizontal asymptote would be at y equals 8. If I had like minus 3 over here, my horizontal asymptote would be at y equals negative 3. So whatever this plus or minus number out to the side is where horizontal asymptote is. If there is no constant out to the side, your horizontal asymptote is just y equals 0. Okay? Now, your horizontal asymptote and your range value. These two values will always match because your horizontal asymptote is giving you a boundary line for your y values. So these values will always match. Okay, we good? So again, we are graphing on our graphing calculator. Pull up the table. Okay? We ready for the next one? Okay, so we're going to go to y equals, and we're going to type in alpha y equals enter to do our 1/2 raised to the x power. Make sure you don't put 0.5, okay? And then we're going to graph it just to visually look at it.
How do you do that raised to the x power?
You hit the little arrow up right below the clear button. And then you hit your x, which is right next to the green button. Looking at this graph, what do we think this is? Is this a growth or a decay? A decay, because it starts up high and then it bottoms out on the right, okay? Or flat lines on the right. So let's go to our table to get our values. Negative 2 is at 4. Negative 1 is 2. 0 is 1. 1 is 1/2, and 2 is 1/4. Okay, so let's plot our values. Again, don't draw your curve until you have your horizontal asymptote drawn. Are we doing this with me? Don't draw your curve until you have your horizontal asymptote. Do I have a plus or minus number out to the side? No, so what's my horizontal asymptote at? Y equals 0. Remember, your horizontal asymptote is a line. It's a horizontal line, so you have to have the y equals. So it's essentially just the x-axis. Draw your dashed line over the x-axis. Now we're going to draw our curve. When we draw our curve, is it allowed to go below the horizontal asymptote that we just drew? No, it like meets it. Is it ever actually going to be 0? We're getting infinitely close to y being 0, but it's never going to actually equal 0. Okay? And we put arrows at both ends. What's my y-intercept? So it's a point though, remember? So 0, 1. What's my domain? Is it ever stopping going to the left, or what do we see at the left of our curve? An arrow. What do we see at the right of our curve? Arrows mean it never stops, right? So what's my domain? All real numbers. Okay, your range. You do have a restriction on your range. Range is y. Am I above or below that horizontal asymptote? Up. This arrow is going up, so it's greater. And then remember, it's the same value as your horizontal asymptote, which is 0. Now here, what's my b value? What's the b? 1/2. So is this a growth or a decay? Because it's less than 1. So this is a decay. Good. How are we feeling about these so far, guys? Again, the horizontal asymptote is really the thing that makes it sometimes a little difficult, okay? But if you just train yourself to know that if there's a plus or minus, what should my horizontal asymptote be here? 0. What should it be here? 0. What should it be here? Y equals -4. Okay, so when you have a constant out to the side, that's whenever your horizontal asymptote changes. Okay, so let's go to number 3. So 3/2 raised to the x power. Again, I always like to graph it to get a visual of what it's going to look like. So that's what my curve's going to look like. Is this going up or down on the right? Up. It's flatlining on the left and going far away from the y-axis on the right. So is this going to be a growth or a decay? It's going to be a growth. Very good. Okay, so let's go to our table. -2 is 4/9. -1 is 2/3. 0 is 1. 1 is 3/2. 2 is 9/4. I want to extend it a little bit, okay? Because more point fit. 3 is 27/8, and then 4 is 81/16. Okay? So I extended it a little bit more because more points fit on the graph. So I'm going to get out of this, second quit. I want to figure out what is that as a decimal. It's easier for me to graph the decimals instead of a fraction. So 4 divided by 9. So this is 0.4 repeating. 2 divided by 3 is 0.6 repeating. Whole number, what's 3 divided by 2? 1.5. What's 9 divided by 4? 2.25. 27 divided by 8. 3.375, and 81 divided by 16. 5.0625. Okay, why am I doing that? It's easier for me to figure out where 5.0625 falls on a graph other than 81/16. Okay? So let's plot our points. -2. And that's a little bit less than 1/2, right? 0.4 is a little bit less than 1/2. Then I'm at -1, a little more than 1/2. Am I going to be super specific with how you're graphing these decimals? No. But does 0.6 need to be between 0 and 1? Yes. Does 0.4 need to be lower than 0.6? Yes. Okay. So then 0, 1. 1 and 1.5, 2 and 2.25, 3 and 3.375, and then 4, and then that's basically 5. Again, before you draw your curve, you always want the boundary line. Do I have a plus or minus number out to the side? No, so where is my horizontal asymptote? zeros. Y equals 0. So that's just the x-axis. So then whenever I draw my curve, is my curve allowed to cross that boundary line? No. Where's your horizontal asymptote? 0, 1. What's my domain? All real numbers. There is a restriction on my range. What's my range? Y is greater than 0. And then this time, my b value. My b is 3 over 2. Remember, b is what's being raised to the power. So my b is 3 over 2. So what is my growth or decay? Is it growth or decay? It's growth. That is greater than 1. So this is growth. And then after you graph it, it's always a good idea to go back and look. Do those look similar? Yeah. Bless you. And again, if it flatlines on the left, that means it's a growth. If it flatlines on the right, that means it's a decay. Okay? We good? We ready for the next one? The next one's going to look slightly different. Okay? So let's go to our calculator, go to y. This time I have a number out in front. So -2 parentheses 3 over 2, close your parentheses, raised to the x power. So let's make sure we're all doing this with me. We all want to be graphing on our calculator with me. So now this time we're below the x-axis. This is where we sometimes struggle with the growth or decay. Okay? Raise your hand. I want everyone to vote. We haven't done any of these yet, so it's okay if you get it wrong. Don't be embarrassed. We shouldn't really know if this is growth or decay. But I want to see y'all vote. Who thinks that this is growth? Okay, who thinks this is decay? So we're heavier on the decay. Okay? Growth people, you are right. Now let's talk about why. 2 reasons. I flatline on the left. What did I tell you about the last problem? If you flatline on the left, it is a growth. We are growing here. We're just growing in the negative direction. Okay? Anytime it's steep on the right side of your graph, that's a growth. Also, what's my b value? Is that bigger than 1? Yeah. So that's why we're growth. Okay? Again, if you flatline on the left, you're growing. If you flatline on the right, you're decaying. It doesn't matter if you're above the x-axis or below the x-axis. Okay, so let's go to our table. Let's see if 3 fits. 3 also fits. So I'm also including 3. Okay, I'm going to figure out what these fractions are. -0.8 repeating, -1.3 repeating, -4.5, and -6.75. So plot your points. This is almost -1. So -2. There. So plot your points. Do I have a plus or a minus over here? No. So what is my horizontal asymptote at? y equals 0. So it's still on the x-axis. So draw your curve. Is it allowed to go above that x-axis? No, because you're not allowed to cross your horizontal asymptote. Arrows at the end. Where does this hit the y-axis? What's your y-intercept, guys? So 0, -2, remember, it's a point. Is there an arrow at the left and an arrow at the right? So my domain is all real numbers. Okay, what's your range? There's only one restriction, so it's y. Are we above or below? Below. This arrow is going down, so is it going to be y is greater or y is less? Y is less than 0. And again, when we're doing our range for our exponential functions, we're never going to put an equal to because you can't equal the horizontal asymptote. You're never going to equal the horizontal asymptote. Yes, ma'am? Because remember, the horizontal asymptote is a boundary line that we do not meet. You get infinitely close, but you're never going to touch it. Okay? We good? Is this a growth or a decay? Because again, my b is 3/2, which is greater than 1. So this is a growth. Good? Okay, next, go to your calculator. Be super careful when we do this one because after we type in the exponent, you have to arrow over to the side to make it a big number again. So I would make sure I'm doing this with me on the calculator. So you type it in, and then you have to arrow over to the side to do your -4. Make sure it's a -4 and not a -4. And graph it. Do we see how the x-axis is no longer my boundary line? Are we below the x-axis? Yeah, are we also above the x-axis? That's why the x-axis is no longer our boundary line. Okay? So let's go to our table. And then let's also do 3. I'm just getting those values off of my table. And again, I'm going to put them in the calculator so I find their equivalent decimal. Oh. So I found my equivalent decimal values for those fractions that we had. So -2, almost 3, 2.75. -1, 0.50, -1, 1, -2, 2, -2.66, 3, -3.1. Now again, before you draw your curve, especially this time because my boundary line is no longer the y-axis, sorry, the x-axis. My boundary line is no longer the x-axis. Okay, so what's my number out to the side? What's my constant? So what's my horizontal asymptote at? Y equals -4. Does that look with the points that we plotted like that's a good boundary line? Yeah. Okay, draw your curve. Are we allowed to cross that boundary line? No, we get super close, but we don't cross it. We don't ever get below it. Again, I'm not going to be super, super strict on our graphing, other than, are you allowed to cross your horizontal asymptote? No, your whole graph needs to be above it. Your whole graph needs to be below it. Okay, what is my y-intercept? 0, -1. What's my domain? All real numbers. Are we noticing my domain for all of these is all real numbers? So until you get to real world problems where these x and y values mean something, if I just give you an equation that's exponential, your domain is always all real numbers. Okay, so until we get to real world problems, my exponential domains will always be all real numbers. Okay, what's my range? It's y. Are we above or below the asymptote? So greater, and where's the asymptote at? -4. So looking at the graph, do I flatline at the right or left? So do we think this should be a growth or a decay? Decay, because we're flatlining on the right. Also, what's my b value? B equals 2/3. Is that bigger or smaller than 1? That's smaller than 1. That's why we are at decay. Good? How do we feel about graphing these and identifying the attributes? It's super repetitive, right? Do we like that? We're graphing and we have a graphing calculator. Do we like that? Okay. We're going to do these next 4 problems and then we're done. Okay. Now, we started the lesson by saying exponential functions are just geometric sequences. So when we wrote our geometric sequences, we needed our first term and our multiplier, our rate. Same exact thing when we are writing our equation from a table. For our exponential functions, we need our beginning value and we need our multiplier. So we're going to use the equation y equals a times b to the x power. That's going to be my equation we are using. Okay, well, what is a? A is the y value of the y-intercept. So we need to find where is x 0. Wherever x is 0, that's your a value. Okay, then we need to find b, which b is just your r, the multiplier for the y values. What am I multiplying my y values by? Okay, so let's look at our table. Do I see a x value of 0? Yes, right here. So what's my b? B is what? 27. It's where x is 0. It's the y value, where x is 0. Okay? Oh, that's not your b. That's your what? Which is your a. I don't know why I put b. That's your a. I'm sorry, guys. I'm losing my mind. So a is 27. B is a multiplier. What do you multiply 3 by to make it a 9? Times 3. So that means my b is 3. Do I now have my a and my b? Ready to write our equation. Y equals a, which we just labeled to be, times b, which we just labeled to be, 3 raised to the x power. Just like always, guys, can we put this in our calculator and pull up the table to make sure it matches? Yes, we should know if we get these right. So go to y equals, and I'm going to type in 20 times 3 raised to the x. 27 times 3 raised to the x. Pull up your table. -2, 3. -1, 9. 0, 27. 181. And 2, 243. Does my calculator match my table? We got the equation right. Good? Okay. Oh no. What do we notice about this one? Do I have an x value of 0? No, there's no x value of 0. We can't find our a then. Not yet. Can we still find our multiplier? Yes, what do you multiply 625 by to make it 3,125? And remember, when we did our exponential, or our geometric sequences, I said you can do the second number divided by the number in front of it. And that gives you your rate, or your multiplier, which is your b. And we're multiplying by what? 5. So times 5. So my b is 5. So we know the b. We need to now find the a. So can I go up to 0? Can I extend my table up? Yeah, tables go two ways. When we're on our table on our calculator, it goes two ways. I can go up, I can go down. All tables go two ways. So if I want to find 0, that's just 1 over 1, right? Well, here I'm multiplying by 5, so how would I go up? Divide by 5. So what is 625 divided by 5? So 125. Because if I'm going down, I'm multiplying by 5. So if I want to go in the opposite direction, you have to do the opposite operation, which is divide. So my A, 125. Now we have our A and our B. We're ready to write our equation. Y equals 125 times 5 raised to the x. Just like when we wrote our geometric sequence equations, can I actually multiply these two values together to make one number? No. Because remember, your order of operations, can you multiply before you get rid of that exponent? No, you cannot. Okay, so that's why all I have to do is find my first term, slash my y-intercept, and then find my b, my multiplier. And then we're done. You just plug it into your formula. So let's plug this into our calculator and make sure we get the right table. Let's all practice this with me. Some of us struggle using the calculators because you don't do them daily with me. So let's all put our fingers on the calculators and we are plugging in 125 times 5 raised to the x power. And then go to your table. So I have 0 is 125, then 1 is 625, 2 is 3,125, and 3 is 15,625, and then 4 is 78,125. Do those match?
Yes.
We did it right. Good? Are you seeing how this ties very closely to our geometric sequences that we already did? Because they're the same type of functions. Okay, next one. Do I see where x is 0? Yes, right here. So what's my a value? 1. What am I multiplying by? Multiplying by 5 would make them bigger. Am I getting bigger?
No.
Say it again. We're getting smaller, but what's our multiplier? 1/5, 0.2, but we want to write it as a fraction, which is 1/5. How did we figure that out? Remember, do your second term divided by the term in front. We get a decimal, we don't like decimals, so math enter, so it's 1/5. Because somebody said 5, so my guess is y'all noticed we were dividing by 5. Dividing by 5 is the same as multiplying by 1/5. So my B is 1/5. So I didn't put times 1/5. So my equation is y equals 1 times 1/5 to the x power. Now guys, do you need a coefficient of 1? No. So I'm just going to rewrite this as y equals 1/5 to the x power. Doesn't this look more similar now to the ones that we did right here? Okay. Would it be wrong if I wrote it like this? No, I'm never going to count it wrong. That's a right answer. This is how you're going to see me write it. This is how you're going to see answer choices. Okay. We ready for our last one? Okay. Oh no, I don't see x being 0, so I can't find my a yet. We need to first find my b. What am I multiplying by? We don't like decimals, so let's go to our calculator. Remember, do your second divided by the 1 in front of it. And we get a decimal. We don't use decimals. How do you change the decimal to a fraction? Math, enter, and I get 1/4. So, just like we did on this one, we need to extend our table up. So it's getting bigger by 1, so I got smaller by 1. So now I'm at 0. We're multiplying by a fourth. What would be opposite of multiplying by a fourth? And dividing by a fourth is just multiplying by 4. So is 5. So my A is 5 and my B is 1/4. So we can write our equation. Y equals 5 times 1/4 raised to the x power. Now, since my table is in decimals, I would always check them, always, but definitely when you have to like extend your table because you don't see the a value, okay? You don't have an x of 0. So I'm going to my calculator, but if I type in 1/4, my table's going to give me fractions, and these are decimals. So I'm going to do 5 parentheses 0.25 because that's what 1/4 is, raised to the x. So then when I go to my table, it's going to give me the decimals. 1, 1.25, 2, 0.3125, 3. Second graph. See how table is written right here in blue? Your calculator is color-coded, so if you hit the blue button, then graph, it pulls up the table. Okay? So do they all match? Yep. Good? How are we feeling? Good. Okay. We are done for today.